Uh, Good morning, all. So today I am discussing about introduction to automata theory in ATFL subject. So first of all, automata theory is a branch of computer science. So that deals with designing abstract self-propelled computing devices that follow a predefined sequence of operations automatically. So an automation with a finite number of states, we can call it as a finite automata. So if you go to the introduction of automata theory, so the term automata is derived from the G code automata, so which means self-acting. Self-acting. So an automata is an abstract self-propelled computing device which follows a predefined sequence of operations automatically. So an automation with a finite number of states, we can call it as finite automation, or we can also call it as finite state machine. So it is a study of abstract computing devices or machines. So automation equal to an abstract computing device. A device need not even be a physical hardware. So a fundamental question in computer science is find out what different models of machines can do and cannot do. So we can go for theory of computation here, and computability and complexity. Here computability means this theory is concerned with what can be computed versus what cannot. You can call it as computability. So what can be computed versus what cannot. Complexity is a concern with resources required to compute the things that are computable. So this is about computability and complexity. So Alan Turing in 1912 to 1954, the father of modern computer science. So he is a English mathematician. So studied abstract machines called Turing machines even before computers existed. So what is a Turing machine? So here Turing test is a method of inquiring in artificial intelligence for determining whether or not a computer is capable of thinking like a human being or not. Next, period of computation, historical perspective. It is started from 1930. Alan Turing studies the Turing machines, decidability and halting problems. In 1940 to 1950, finite automata, machines studied Noam Chomsky, proposed the Chomsky hierarchy for formal languages. In 1969, Cook introduces intractable problems or NP-hard problems. And in 1970, modern computer science like compilers, computation and complexity theories evolved. So here languages and grammars, an alphabet is a set of symbols where we can call it as 0, 1. Sentence or string of symbols, we can also call it as words. A language is a set of sentences of finite length, all constructed from a finite alphabet of symbols. So if it is infinite, then we can call it as a language. So language should have a finite set. A grammar is a finite list of rules defining a language. A grammar can be regarded as a device that enumerates the sentences of a language. Nothing more, nothing else. So Noam Chomsky Information and Control, Volume 2 in 1959. So Chomsky hierarchy, according to Chomsky hierarchy, so regular grammar, context-free grammar, context-sensitive and recursively enumerable language. It is a contaminant hierarchy of classes of formal language. So next topic, the central concept of automata theory. The first you can call it as alphabet. So the definition of an alphabet is any finite set of symbols, and it should not be non-empty set. So if you take an example, if we use a symbol sigma, Okay, to denote an alphabet. And if you take an example, binary, suppose sigma equal to A, B, C, D is an alphabet set where A, B, C and D are symbols. Okay, so in binary we can call 0 and 1, lower cases A, B, C to Z, and if you call alphanumeric, then you can say A to Z, capital A to Z and 0 to 9. So DLA molecule letters are A, C, G, T, these things. Next is strings. So a string is a finite sequence of symbols taken from sigma. So empty string you can call it as epsilon. So the length of a string W denoted by W is equal to the number of non-epsilon character in the string. Suppose if I take an example, x equal to 0, 1, 0, 1, 0, 0. Now the modulus of x equal to 6. Concatenation of two strings x and y. So if we have a string like this C A B C A D, so which is a valid string on the alphabet set that belongs to A B C D. From A B C D only we have written a word called C A B C A D. So what is the length of the string? So length of the string is number of symbols present in a string. Okay, number of symbols present in a string. So power of an alphabet. Let sigma be an alphabet. Sigma power k equal to the set of all strings of the length k, and sigma star equal to sigma 0 union sigma 1 sigma 2 and so on. So we can call it as a clen star. So is an unary operator on the set of symbols or strings. So that gives us the infinite set of all possible strings of all possible length over sigma including lambda. Sigma plus we can call it as clean closure or plus. So the set is the infinite set of all possible strings of all possible lengths over sigma excluding lambda. We can represent with the help of x sigma 1 union sigma 2 union sigma 3 and so on. Next, language. So a language is a subset of sigma star. For some alphabet sigma, it can be finite or infinite. Example, let L be the language of all strings consisting of n zeros followed by n ones. So L equal to epsilon comma 0 1 0 0 1 1 and so on. Let here L be the length of all the strings of with equal number of zeros and ones. We observe the previous example here. So the length, so whatever you have taken, so they are equal zeros and equal ones. So 0 1 here 1 0 is there, 1 1 is there, and 2 zeros 2 ones are there. The same way you need to mention the length. Canonical order of strings in the language here. Definition: find denotes the empty language. So next class we will discuss about the remaining topics like. Thank you.